Alright guys, more fun. We're gonna do video 18.1 transformations. Okay, I'm gonna put out the notes for page 52.1, and for now, just relax, copy it down. It's not gonna seem as bad as it looks. Okay, so if you have a function, okay, your parent function, your original function is f of x. Alright, and then you make these changes to that function. Without graphing it, you can tell which way it's going to go. So look, in this case, you've added h into the operation, so it's going to shift it left h units. Okay, and you would think because it's positive h, it would shift it right, but when it's in the operation, it's always going to be the opposite. So look, plus h in the operation shifts it left h units. Look, subtract h units, you're going to shift it right h units. If it's on the outside of the operation, look, plus k is just going to shift it up k units. And if it's minus k on the outside of the operation, it's going to shift it down k units. This will make much more sense when I show you some examples. If you do a number, the absolute value is greater than 1, it'll take your picture. If you throw it in front of the whole function like that and multiply, it'll actually just stretch the graph, okay? And here it'll truncate it, it'll compress it if you get an a value whose absolute value is less than 1 but greater than 0. It's a fraction value, okay? And then finally, if you negate the whole function, you're going to end up flipping it across the x-axis. So if it's opening upward, now it's going to be opening downward. Okay, again, this is a lot of information. All right, so just kind of jot it down for now. And the neat thing is you only got to learn this once, and it's going to apply to the absolute value ones that we're doing. It's going to apply to the quadratics that we're doing. Pretty much anything that we do in here will act this way. Okay, so what am I trying to say? Again, what is Mr. Mac trying to say? So let me find you this graph paper. All right, I'm going to zoom in here. Oh, that's just a work of art, absolute work of art. All right, so it says f of x equals the absolute value of x, okay? It's an absolute value in two variables. All you need to know is the parent function, all right, is a v, what we call v, hits at the origin, 0, 0, the vertex does. All right, so look, this baby right here, all right, is your parent function. All right, if for whatever reason you forget, okay, and it happens. I mean, you can't remember everything in this class because there's so much information. Look, you can select some x values. I would just select 1, negative, 0, and 1, okay? And think about it. If you plug these three x's in for the absolute value of x, you know what's going to happen. The absolute value of negative 1 is positive 1. The absolute value of 0 is 0, and the absolute value of positive 1 is also 1. And that's why, look, these values went back up, okay? All right, we're cool. This is function f of x. All right, so keep that in mind, okay? All right, I'm going to fold this, and I guarantee you're going to relax when you see the first example. All right, so that's your parent function right there, right? All right, the first thing they want to know is, okay, cool, so you have f of x equals absolute value of x. What if I put a plus 2 inside the absolute value bars? All right, so y'all look at your notes that you just took. That's inside the operation. It's plus 2. What's that? Yes, it's going to move 2 units left. If you've downloaded Desmos, like I told you, type it in there. Type in y equals absolute value of x, then type in y equals absolute value of x plus 2 and see what happens. Okay? All right, example 2 over here. All right, f of x equals absolute value of x minus 2. That minus 2 is what? On the inside of the operation, so it's 2 to the right. Okay, when you get to example 3, that plus 2 is what? On the outside, so it's up 2. Here would be what? Down 2. Number 5 is bigger than 1, that coefficient of 2, so this is a stretch. Okay, hopefully I spelled that right. Make sure I spelled that right. All right, this one's absolute value is less than 1, so this is compressed, shrunk down. Okay, and then finally, one beautiful one, if you change the coefficient sign right there, it'll flip. Okay, wow, cross x-axis. All right, and if you're confused, here, look over here, just one more time. When we have the answer key here, just take one more moment and look at all of these notes, and you'll see that's what we did. When it was inside the operation, it moved left or right, didn't follow the sign. When it was outside the operation, it moved up or down, but did follow the sign. Here's your stretch and your compression and that. We're gonna do this with the quadratic, and it is gonna be the exact same thing, okay? It's just crazy, all right? So let me draw you the quadratic, and then you're gonna love that you're gonna absolutely do the same thing. All right, so let's try this parent function. I'm gonna zoom in. The only thing different, look, it's not absolute value. Yeah, I'll tell you what, let's just go ahead and make the table first. You won't have to make the table after a while because you'll get used to this. And again, just pick -1, 0, and 1. You're gonna notice it behaves a lot like the absolute value one did. All right, if I square -1, I get +1. If I square 0, I'm gonna get 0. If I square 1, I'm gonna get 1. Okay? The only thing different is because you have that squared power there, you have to know that after you plot these points, that it's a curve. And then here comes your curve. So it's a lot like the absolute value, except for we actually curve the graph, okay? All right, the parent function is what? Yes, y = x². Oh wait, that was an excellent question. Yes, absolutely. If you want to put that in function notation, you can also do that. So you can literally pick any capital letter you want. Let's just do something different. I'll use G. So you can say g of x